Okay, so today we're going to be talking about circles. This is the intro to our circle unit. So the first thing we're going to talk about is what exactly is a circle? Well, by definition, a circle is a locus or bunch of points that are equidistant from a given point or the center point. So it's a bunch of points that are the same distance from the center. And I'm going to try to draw you guys a circle on here. It's going to be a little bit hard, so please ignore it if it's not perfect. And here is my center. All the distance away from this center have to be equal. So this distance and this distance have to be the same. This distance and this distance all have to be the same. They all have to be the same distance away from the center of my circle. Okay? So that is what circle is. Now let's talk about the radius. The radius is a line segment that extends, line segment whose endpoints are the center of the circle and the circumference. I can't spell. So, a radius is a segment whose endpoints start on the center and end somewhere on the circumference. So this would be considered our radius. It is from the center out. It can be from any direction. This can be our radius. This can be our radius. It doesn't matter as long as it's from the center to the edge of our figure. Okay? Let's talk about the next one. What is a chord? A chord is a line segment that endpoints are a chord is a line segment whose endpoints are on the circumference of the circle. So I'm going to give you guys an example. The two endpoints are on two different sides of the circle, like this. This is called our chord. Again, it can be from any direction as long as the two endpoints lie on the circumference of the circle. You can have multiple chords in one figure, like that. But it all has to, the two endpoints have to be on the circumference. It cannot intersect. It has to be directly on the center of the circle. Or on the circle, the circumference of the circle. Okay, so let's go to the next one. We finished with chord. Let's talk about diameter. Diameter is a chord who goes through the center of the circle. So a diameter is just a special chord. It's a chord because its two endpoints have to lie somewhere on the circumference of the circle, but it has to go through the center. So it has to go through the center. It is the diameter. A good way to look at it is there is a formula to go from diameter to radius. We know radius is from the center to the circumference. The diameter goes from circumference through the center to the other side. A formula for diameter is 2 times the radius. Or if you're trying to find the radius given the diameter, the radius is 1/2 the diameter. Those are going to be important in a few minutes when we go over different questions. So make sure you guys at least know the difference between diameter and radius as we go into the next section. And then we're going to talk about arcs and central angles. An arc is a section of the circumference of a circle. So a section of a circumference of a circle. And what do I mean by that? Well, let's start by drawing one out. Let's start here. Okay. So, and let's just say if I made 2 points on my circle, this is A and B. If I were to draw a line from A to B, like that, that would be arc AB. So it's just the consisting of these points inside the 2 endpoints. So it has 2 endpoints on the circumference, and everything in between is our arc. Okay? Now, the way we can look at arcs and the way we figure out the distance or the degree of arcs is based on the central angle. A central angle is an angle that consists of 2 radii, and the vertex is the center. So the central angle is an angle that consists of 2 radii, and the vertex is the center of the angle. So an example would be like this. So if this was O, the angle AOB would be considered a central angle. And if you're talking about the angles that consist of arcs, the arc that is related to AOB is focused on its 2 endpoints. So if we're connecting arcs and central angles together, focus on the 2 endpoints. Whatever's inside the angle, as in this right here, would be the arc that corresponds with the angle AOB. Okay? Now let's talk about circumference again. Let's talk about the circumference of a circle. How can we find the circumference of a circle? Well, there is a specific formula that we're going to use. Make sure you guys know the definitions. I'm going to throw these to the side for right now. We're going to come back to those later. Okay? So let's look at circumference. The circumference of a circle is the distance around the circle. The distance around the circle. So let's focus on what that means. Well, there is a specific formula that we're going to use in order to find the circumference. Now, it all depends on which information you're using. There's going to be 2 formulas. The first one is going to be C. Circumference is always written with an uppercase C. Keep that in mind. Uppercase C is circumference. Circumference is pi times the diameter. Or circumference is pi times the radius times 2. The reason we do 2 times the radius is because 2 times the radius is the diameter. Now, depending on what you have, use this information, okay? So let's start. Let's figure it out. Now, the first thing we need to discuss is pi is a number. Pi is a Greek letter and is written like this. It is a Greek letter that describes the relationship between the circumference and the diameter. They found this out a long time ago, and they know it's going to be about roughly 3. We know it's about 3.14159 something else and a bunch of other numbers. So we're only going to look at it in terms of 3.14 unless you have a calculator. And we're going to, most of the time, leave it in terms of pi, so you won't even have to calculate this out. So I'll let you know, in the meantime, which one we're going to use. If it gives you an approximate answer, you're going to use the number. If it does not, you're going to leave it in terms of pi. So let's start off by finding the circumference of a specific number. So let's find the circumference, given the radius is 7. Now in this one, we're going to leave it in terms of pi. So we know the radius, meaning we're going to have to use this formula. If we know the radius, we're using this formula. So we're going to start off. We know c is equal to 2 times pi times our radius, or 7. Well, 2 times 7 is going to be 14. 14 times pi is going to be 14 pi. We're leaving it in terms of pi. I'm going to say 7 inches. That way we can keep units. So the circumference is 14 pi inches. And you can leave it just like this. You don't have to do anything else. Okay? Well, let's do a different one. Let's do one more. Find the circumference this time if diameter is equal to 12.5. Well, let's figure this one out. So the diameter is 12.5, and we know circumference is pi times the diameter. So we're going to do c is equal to pi times our diameter, or 12.5 centimeters. So the c is going to equal 12.5 pi centimeters. Now I'm going to give you guys an approximate answer of what c is, and your goal is to find the diameter and the radius. So we're going to find the diameter and the radius. Given the circumference is about, let's see, 143, no, 136. Let's do 136.9. Okay? Well, let's start with the diameter. That seems a little bit less intense. So let's start with finding our diameter. Well, we know the circumference is equal to pi times the diameter. And our circumference is 136.9. Sorry, 136.9. Get rid of that decimal right there. Is equal to pi times our diameter. Well, I need to figure out what the diameter is, so I'm going to have to divide both sides by pi. You can either do this on your calculator, or you can change this number to 3.14. I don't care which one you use. I'm going, as long as it's an approximate answer. So we're going to do 136.9 divided by pi. If you type that into your calculator, or if you want to, 3.14. If you want to use that instead. The diameter is going to be roughly 43.6. Now before, we discussed what diameter is compared to the radius. And if you remember, the diameter is equal to 2 times the radius. If we're trying to find the radius, and we know the diameter, or 43.6, we know that's equal to 2 times r. We need to get r by itself. The 2 is multiplying the r. We're going to do the opposite. We're going to divide by 2. 43.6 divided by 2 is going to be about 21.8. And that is our radius and our diameter. We've talked enough about circumference. Let's talk about area next. Area of a circle is different. The area of a circle discusses all the space taken up by our figure. So we're going to talk about area. We're going to talk about space taken up by the figure. Okay? So let's start with this. The area formula is a little bit different. An area is written with an uppercase A. The area of a circle is pi times the radius squared. That's it. So if we're given a radius, say if this radius is 2 inches, we need to find the area. So the area of a circle we know is pi times our radius squared. So we're going to leave it in terms of pi 2 squared is 4. Anytime you guys are working with area, this is the first time you've probably seen area this year. The area is going to be units squared. Circumference is just units because it's measuring distance. Area is measuring space in a section, so it's going to be units squared or inches squared. That is our area. Well, let's give another example. Let's use another one. Let's find the area given the diameter. Let's say 13. This time, we are only given the diameter. We do not know what our radius is. So the first thing we need to do is figure out our radius. Well, we know the radius is equal to 1/2 the diameter. So R is going to equal 1/2 times 13. So we're going to do 13 times 1/2. And that's going to give us, the radius is going to be 6.5. Now that we have our radius, we're going to plug it back into our formula. We know the area is equal to pi times our radius squared. Well, 6.5 squared is going to equal 42.25. And we're going to leave it in terms of pi. So it's going to be 42.25 pi centimeters squared. Make sure you put the units. That's very important. Put the units in this question. Okay? Let's do, when given the area, let's find the diameter. So we need to figure out what the diameter is. Given the area, let's say our area is equal to, I don't know, 78.5. Yeah, that sounds right? So the area is going to be 78.5 millimeters squared. This is an approximate answer. We're going to have to work on this question. The first thing we know is the area is equal to pi r squared. So we know 78.5 is equal to pi times the radius squared. Well, the first thing I know is pi is a number. So I'm going to rewrite it as 3.14. That's the one I'm going to use. 3.14 times r squared. We're going to divide both sides by 3.14 in order to get r by itself. And I'm going to move the diameter over here. That way we have more space. Well, 78.5 divided by 3.14 is going to give you 25. Those are going to cancel out, leaving us with just r squared is equal to 25. Well, we still need to get rid of our square. We're going to take the square root. The square root of 25, it breaks down into 5 and 5. The square root of 25 is 5. That is our radius. We are asking for the diameter. If the radius is 5, remember the diameter is 2 times our radius. So the diameter would be 2 times 5, or 10. And make sure you put millimeters. Keep the same units. The diameter is 10 millimeters. Okay, now let's move on to our central angles and chords. Those are going to be super important, or arcs, not chords. We'll go back to chords later. Central angles and arcs. Let's start off by writing our arcs and writing our central angles, and then we're going to answer some questions, okay? Here is my circle. Oops. Wow, that's pretty bad. Oh well. Let's see if I can fix it. Good enough. Okay, so here's my circle. There are 3 different types of arcs. There are major, minor arcs, degrees less than 180 degrees. Major arcs, degrees greater than 180, and semicircle. Where the degree is equal to 180. Here's an example of a minor arc. This angle right here is clearly less than 180 degrees. The arc that it creates, like this one, AB, arc AB, would be a minor arc because it is less than 180 degrees. Let's do an example of a major arc. A major arc would consist of an arc that is greater than 180 degrees and is written with 3 letters. If it is a minor arc, you can write it with 2. If it's a major arc, it has to be written with 3 letters. The reason why is it needs to let you know that it is not talking about this section right here. If you say, oops, wrong color. If you say arc AC, it is only talking about the blue. If you say arc ABC, you know B is part of the line, making it your major arc. And then a semicircle is a little bit different. Let's look at the semicircle. Again, semicircles also have to be written with 3 letters. You only need 2. You can write more, but you only need 2 for a minor and 3 for major and semicircle. A semicircle makes exactly half of the circle and is written as A, B, C. You have to write 3 letters again to tell you which side of the circle you're looking at. Arc ABC is clearly the top half. If you do arc ADC, it tells you it's the bottom half of your circle. Now let's talk about arcs and central angles, degrees. The central angle, let me type this up. The central angle gives the degree to the arc. Hold on, that's a bad way of writing it. The central angle is congruent to the degree of the arc. The central angle is congruent to the degree of the arc. So if I were to give you an angle like this, and I said this was 140 degrees. Angle ACB is congruent to the arc length of A, or arc degree of AB. So this arc measure is the same as the measure of its central angle. So 140 is the degree of ACB. So that means that is the measure of AB. Okay? Let's go on to a different one. Different example. And remember, the endpoints of your angle gives you your arc. I'm going to draw a little bit more elaborate picture this time. Oh, that was bad. Oh well. So this time we are going to name the central angle for this one. We're going to name the central angle. With the arc. So if I were to give you an arc, we're going to have to name our central angle. So let's start with this one. I want to find the angle for JLK. So we're going to start with JLK. If it goes from J to L to K, that means we're going in this direction. So I'm going to highlight the chord that I'm looking at, or the arc, the arc that I'm looking at. So it goes from J to L to K. It will not go this direction because it specifically says go to L next. J, L, K. Not JKL, JLK. So we're looking at this large angle. And the way we're going to look at this is, we're going to start by writing our central angle. Well, the two endpoints of our angle are going to be J and K. And of course the vertex is the center one right here. So let's find our central angle. I'm going to label it I'm going to label this one O. The angle is going to be from J to O to K. This is the angle that's going to focus on it. Whatever this angle degree is going to be the degree of our arc. Let's do one more just like it. And then we're going to go over one or two questions for the other part, and then we'll be done for today. Wow, that's bad. We're going to find the central angle for M, or for NO, for this arc right here. We're going to start by highlighting our arc. So it goes from N directly to O. It does not pass P. If it were to go the other direction, we would have to write NPO because it tells you the next one it has to go to. But we're not looking at that one. We're just looking at NO. So the degree, or the central angle, its two endpoints are going to be the endpoints of the arc. And the vertex is the center of the circle. So it's going to be N, M, O. That is our answer. Wow, I wrote that really weird. Okay, now let's go over 2 or 3 examples of finding the degree. And we will be done for today. So let's start with an easy one. So the central angle is congruent to the degree of the arc. So let's start with this. So we know this arc right here is 60 degrees. We want to figure out what this central angle is. Well, we know the central angle is congruent to the degree of the arc. And we know that this is our center. So that means this degree has to be equal to the degree of our arc. So this question mark has to equal 60 degrees. Let's do another one. Excuse me. Let's do a little bit harder this time. That's a degree symbol right here, 51 degrees. And then, let's find H. We are going to find the measure of H, D, F. Well, first off, let's look at HDE. Let's look at this part right here. And we know that this part right here is the center of our circle, and this goes directly through it, making it the diameter. If that's the diameter and it takes up this whole arc, that means that is exactly 180 degrees, meaning this part is also 180 degrees. And we want HDF, so we want all this red right here. That's what we're looking for. HDF. Well, EF, we know its central angle is 50 degrees. So that means this side has to be 50 degrees. Well, if this is 180 and that's 50, 180 plus 50 is going to give us our degree. So 180 plus 50 is going to be 230 degrees. So this whole thing is 230 degrees. Let's do one more. This is going to be my center. Again, I apologize for the drawings. They're pretty bad. Okay, so we want to figure out what x is. That is our whole goal right now. And we are going to assume everything that looks like a diameter is a diameter. An example, this right here is a diameter, making all of this 180 degrees. But we'll come back to that. We don't need that yet. So first off, let's focus on this 125 and this 85 degrees. We know 125 is made up of two lines. This line and this line intersecting. So if these two lines intersect, that means this angle is vertical to this angle. The whole thing. So this one is 125. These two together have to be 125. We need to figure out what this angle is first. So we know 85 plus P is equal to 125 degrees. And we're going to subtract 85 from both sides. 85 minus 85 is 0. P is going to equal 125 minus 85 is going to be 40. And you're asking me, why are we doing this? Well, we need to figure out this section here. If we figure out this section, we can solve for x. We know this is a semicircle because this line right here is the diameter, meaning all three of these angles have to add up to 180 degrees. Let's solve for this angle right here in order to figure out what x is. So we're going to set it up as, we don't know that one, I'm going to label it as y. Y plus 85 plus 40 is equal to 180 degrees. 85 plus 40 is going to be 125. We're going to subtract 125 from both sides. 180 minus 125 is going to be 55 degrees. We know 55 is going to equal x plus 57. Why do I know this? Whatever this angle is going to equal the total degree of our arc. So if this angle is 55, like we just discussed, then this arc is going to be x plus 57, is going to have to equal 55, because that is its central angle. So we're going to solve for x. I'm going to subtract 57 from both sides. X is going to equal -2. Let's do a little bit less intensive one. And we'll move on from there. Actually, I think that's all the time we have for today. This film is getting a little bit long. If you guys have any questions, please let me know. If you need any extra help on these concepts, please message me on Schoology. Other than that, you guys are free to go. Please work on